Hi, my name is Darren, and my partners Joyce and Andy and I's project was to project retail sales using advanced machine learning techniques. So going into this project, we understood how important it is to project sales, especially for the retail industry, to allow them to be able to perform tasks such as being able to optimize pricing strategies and supply chains, especially to drive profitability. So for this project, we accessed data from the UC Irvine Machine Learning repository of a UK-based company and their transaction history from 2009 to 2011. Our main objective was to project retail sales by forecasting customer shopping behavior. And doing this, we had two questions that came to mind. One, how does the price of an item impact the quantity sold? And two, how can we predict annual sales cycles and trends? So for the first question, our first EDA was creating distribution plots for revenue, price, and quantity. Doing this, we examined the presence of outliers and overall distribution of transaction behavior. What we observed were a high number of outliers, and since our revenue outliers may have been due to abnormally high sales quantities, items, prices, and both, we came to the conclusion that there were also common outliers for revenue and quantity, as well as revenue and price. For our second EDA, we created a scatter plot to depict the relationship between price and quantity. Doing this, we observed a general negative correlation between price and quantity. However, we also observed that a wide range of quantities sold per transaction was evidence for cheaper items. So evidencing more quantities or less quantities.
We tested a few different models before settling on the basic polynomial and decision tree regression models as our baselines, based on them having the best test MSE scores. To tune the polynomial regression model, we used k-fold cross-validation and lasso regularization. And then to tune the decision tree regression model, we used grid search cross-validation and AdaBoost. And ultimately, we concluded that the single decision tree model of depth 8 was the best, based on accuracy, computational efficiency, and performance consistency. So our polynomial regression models yielded higher MSE scores than our decision tree models, which is why we selected our final model from those tested in the decision tree process. As you can see here, the single depth 8 and depth 60 trees had nearly identical performances, but we selected the depth 8 tree since it is less computationally expensive. And our results were a little bit unexpected, since we would usually expect an ensemble model like boosting to improve the performance of a model. But this is likely just due to the fact that we're only dealing with one predictor here, although we went ahead as we would if we had multiple predictors within the scope of the course.
Next was exploring how to predict annual sales cycles and trends. And to explore this, we created a series of 3 time series graphs for total revenue over time, as well as for the 2 most popular items. Looking at this illustrates the seasonality of certain products, especially depicting a relationship between invoice dates and demand. And there appears to also be peaks at specific time periods, especially in October and January, pointing to higher revenue and higher transactions, especially during the holiday time period.
For time series analysis, we performed more in-depth testing that you can see in the notebook report. And then we created 3 basic time series models, the autoregressive, moving average, and ARIMA models. The baseline ARIMA model had the lowest RSS score, so we further tuned this one by testing various combinations of hyperparameters. And then we performed preliminary forecasting of our revenue using our tuned ARIMA model. And the results of this forecasting are depicted here. And you can see that it's a bit more accurate and closer to the in-sample model fitting.
Now for our conclusions, let's go back to the questions we asked in the problem statement. Mainly, how does the price of an item impact the quantity sold? This is a little difficult to model because prices are non-continuous, but we saw that generally, as the price increased, demand for that item decreased. Now for the second question, how can we predict annual sales cycles and trends? Again, because of the volatility of the data, it was a little difficult to predict beyond general trends. Now, for further work, our data was based on one retailer in one country. This poses a question as to whether it generalizes to the greater economy. So in future work, we'd want to encompass, different retailers from different countries. On top of that, we'd want to examine the relationship between revenue and of the item and the other characteristics of that item. Additionally, we'd want to add more complexity to our time series model, maybe expanding to a SARIMA model to encompass more of that seasonality that we saw in the exploratory data analysis. And finally, we'd want to encompass how macroeconomic situations can affect our results. Notably, our data goes from 2009 to 2011 and excludes the great financial crisis. So we would want to see how things like recessions and consumer confidence can influence our sales. And with that, this concludes our project, and we'd like to thank you all for watching.